This is the second part of the video for the final exam review, and we're going to pick up on number 25. Okay, so solve. Please notice that anytime you have an equation with a greater power than 1, in other words, you have exponents that are greater than 1 in your equation, and the only way to solve that equation is to set it equal to 0. So you cannot try to solve for x when you have multiple exponents. Factor, you have a GCF, you can pull out an x. That leaves you with x squared. Once you pull out your x, you're left with a quadratic that you can factor. 2 factors of 12 that add up to 7, or 3 and 4. And then you basically set each factor equal to 0 and solve. So of course you get x equals 0, -3, and -4. And there are your answers. Okay, word problem. Rectangle has a table. A rectangular table has an area of, always draw it out, 45 square feet. The length of the table is 1 foot less than double the width. Okay, we know a lot about the length. We don't know anything about the width. We're just going to call that W. But length, we're going to write in terms of width because we now have some information about it. We know it is 1 foot less than, so that's -1, double the width, 2W. Find the dimensions of the table. So you know how to do an area. Area equals length times width. Don't know why I wrote it that way. So 45, 2W squared minus W. Again, anytime you have an equation greater with an exponent, you've got to set it equal to 0. And we need to solve that. You can use the AC method by doing 2 times -45, which gets you to -90, 2 factors. And you can go through that process. You have -90, 2 factors that add up to -1. Oh, looks like it's going to be 9 and 10 would actually work here. -10 and +9. But then you have to split that up. The -W, you have to split up -W into -10W plus 9W and use the grouping method. Or if you're moving on in pre-calculus and calculus, get used to doing quick. Here's why I say you can do this one quickly. 2W squared can only be broken up into 2W and W. So all we need to do is figure out some factors of 45. That when I work them out, this times this and this times this gets me to -W. So 9 and 5, they're your kind of most common factors. I don't want to do 2 times 9. I don't want to put the 9 here because that's going to give me way too big a number. But what if I put the 5 here and the 9 there? Let's think about that. 2 times 5 is 10W. 9 times W is 9W. All I need is for this one to be negative. -10W and 9W gets me that -W. So I follow the path. Just follow it along and make that one the negative and that the positive. And it works out very nicely. Or again, you can use the entire, you can use that AC method that we started. So I have 2W plus 9W minus 5, set each equal to 0. This is going to give me a negative. You cannot have a negative area. You simply cross that one out. This is the one I want. The width is 5. And then let's see what this is. 2 times 5 minus 1. 10 minus 1 is 9. And we're done. Okay, simplify. Again, we're back to our exponents. First of all, match up your common bases. 42 over 24, both can be divisible by 6. 6 goes into 42 7 times. 6 goes into 24 4 times. So that reduces to 7 over 4. Notice the A's. That's going to give me, quotient rule is 4 minus 7. That's A to the negative 3. Since it's negative, we write it in the denominator as a positive. Look at the B's. Well, that's B. Look at the B's there. I'll do them in a different, yeah, it's fine. Look at those B's. 1 minus 1 is 0. The B's good, they just cancel. They're the exact same. C3 just stays up there, and that is your answer. This one's a bit more complicated. Whenever you have a division, notice there's no equal sign here. We cannot combine these. We're not solving an equation. What am I left with? 3x plus 9 over 5x minus 20. Division becomes multiplication, and I flip these. But as I flip them, I'm also going to factor them and save myself a step. So notice x squared minus 8x plus 16 is x minus 4x minus 4 factored. Top one is a little bit more complicated because we have a 3 we need to pull out. I'm going to do that off to the side. So it looks like it's going to be minus 4 and plus 3 because that's going to give me the negative 1 and multiply together to give me negative 12. So that goes down here, 3x minus 4. So I flipped it, but I factored as I flipped it. The first part stays the same, except I'm going to do the same here. Now take a look. 3x plus 9. Let me factor that. 3x plus 3. And then 5x minus 20. Let me factor that. 5x minus 4. We have a lot of things that can cancel. Lots. The 3's can cancel. The x plus 3 can cancel. This x minus 4 cancels here. This x minus 4 cancels here. What do we have left? Okay, notice I have nothing left in the denominator. That just means there's a 1. The answer is actually 1/5. That's all I have left in that problem. Now, subtraction is a little more complicated. We are going to go ahead, when we're dealing with subtraction, we have to get these common denominators. So at this point, we really only care about the denominators. So to get started on this problem, I'm just going to figure out what this denominator is factored. Right, and y plus 6. So let me get that factored. Y squared plus 8y plus 12 is y plus 2 and y plus 6. Okay, don't worry about the numerator, just the denominator. I need a common denominator. This first fraction has y plus 2 and y plus 6. See, the second fraction only has y plus 2, y plus 6. We're missing a y plus 2. Well, I can introduce it as long as I introduce it as a fraction because, you know, y plus 2 over y plus 2 simply equals 1. And 1 times anything doesn't change the original fraction. So I'm going to bring this together as one fraction. So let's take a look at what I have now. my numerator. Okay, so here's what I got right now. Minus. Now, at this point, you might be tempted to cancel those y plus 2's, but that just takes us back to the original problem. We don't want to do that. What I want you to notice is right now, I have common denominators, which means I can write this as one fraction, and that's our goal. Bring it together as one common denominator. Now, you'll actually get a good amount of points for getting to this point, but we really need to clean up this. How do we clean that up? Well, first of all, I need to focus on this part here. Yeah, so off to the side, I'm going to figure out what 2y plus 1 times y plus 2 actually equals. So I'm going to FOIL it out. And that's going to give me 2y squared plus 5y plus 2. So notice, I still got that minus out front though. Be careful. This whole thing becomes 2y squared. In fact, I'm going to go ahead and erase it. Oh, not that. Didn't mean to erase that part. Hold on. And put that back. And this is what I have. But I have it negative. So I now need to distribute. So let's see what this looks like so far. Okay, all over. And now I'm going to clean it up some more. Oh, that gives me that y squared negative y squared. Sorry about that. Y squared minus 2y squared is negative y squared. 2y minus 5y is minus 3y plus 18. Don't forget, it's always over this. And you can work on the, if you want to take the denominator off to the side and work on it on its own first, you can certainly do that. It's a little bit neater. All right, I'm going to pull out a negative 1. Again, you're going to get a good amount of points for getting to this point, but one of the first things you learn is how to simplify an algebraic rational expression, and that's what we need to do here, because you can factor this. Let's do it. What is that? Y plus 6, y minus 3. Everyone agree? 6 times negative 3 is negative 18. 6 minus 3 is positive 3. And what do we get? The y plus 6's will cancel. So I have negative y minus 3 over y plus 2. That is our final answer. It's a long problem, but that is the correct answer. Now, simplifying a complex fraction. There's different routes you can take to doing this. You can take the denominator and numerator separately and try to get them into one fraction, then do basic division. I like to just look at I like to find all of the denominators. There's a denominator and there's a denominator. And I'm going to multiply each term by that denominator. And what does that mean? Well, I'm going to multiply this whole fraction by x minus 1 over x. Notice they are different, x minus 1, x plus 1. So you can multiply the whole thing by x minus 1, x plus 1 if you choose. Notice that's just 1. When you distribute in the numerator, notice the x minus 1's cancel. And what are we left with? 2x plus 1 over x plus 1. Now, be careful, though. In the denominator, we actually have two terms. We got this term and that term. It has to distribute to the 1 and then distribute to the fraction. Well, 1 times that whole thing is simply, okay, plus. Now, these will cancel, and I'm left with x times x minus 1. So that whole complex fraction looks like this. You've got, but to clean this up, we have to do some foiling. All right, you have to do some foiling. So the first thing I would say is you need to FOIL the numerator out. Or actually, I wouldn't FOIL the numerator yet. Let's leave the numerator as it is. Don't jump ahead to do that yet. You definitely have to do the denominator because you've got this big plus sign in the middle. So we need to get this and we need to figure out what that is. So let's do that underneath. What do we have? X minus 1, x plus 1. Work it out. It's going to be x squared minus 1. Middle terms are going to cancel. It's going to be x squared minus 1 plus x squared minus x. So what's that going to give me? That's going to give me 2x squared minus x minus 1. Can I then factor that? Well, sure. 2x is x and x. 1 can only be 1 and 1. What would work? One of them has to be negative. I believe it's that one, because that's going to give you negative 2x, right? Negative 2x plus x is negative x. So over here, I can put 2x plus 1, x minus 1. Cancel, answer. You cannot do anything with that. They are not identical. The x's cannot cancel. That's your answer. There is a second method to that. Method 2 is simply to leave the numerator as it is. But the denominator bring together as one fraction. So what do we have? We have 1. This is the denominator. All right, so you can multiply by x plus 1 over x plus 1. I get x plus 1 plus the other x over x plus 1. And that gives me 2x. So if I replace my denominator, because I brought that together, and I replace it with 2x so all I did in this method was to take this denominator and make it one fraction. That denominator became that. Okay? In doing that, sorry, what that lets me do, let me erase this over here now, is do a simple division. Okay, this is a division symbol, that big fraction bar. So I have 2x plus 1 over x minus 1 divided by 2x plus 1, which is 2x plus 1 over x minus 1 times the reciprocal, cancel, and I get the same answer. So there's different methods of doing that particular problem. It depends on how it's originally set up. This one was probably easier to do method 2, but some of them it's much easier to do method 1. Equations. You must know how to do this. This is different from the ones above. We now have an equation. We have to treat it differently because it's an equation. Factor, always factor first. Factor your denominators. So just your denominators. So what's that? 2x. Looks like I would do this, right? Let's see if it works. That gives me an x. That gives me a 6x. I need this one to be negative, so I'm going to put my negative sign there. And that one to be positive. That seems to work. I get negative 6x, and x is negative 5x. 1 times negative 3 is negative 3. Good. All right, so I factored it. There it is. What are all my factors? Well, let's take a look. I have, look at those denominators. I've got a 2x plus 1. That's my first denominator. Then I have an x minus 3. Oh, there's another x minus 3. There's another 2x plus 1. So this is my common denominator. Or my lowest, the other thing is it's also the lowest common multiple. You want to multiply each side of your equation, and we're going to distribute, so we're going to do each term actually, by 2x plus 1 times x minus 3. 2x plus 1, x minus 3. 2x plus 1, x minus 3. We're going to multiply every term by all that. It looks messy, but watch what happens. The entire denominator cancels. On the first one, I just have 2x minus 10. What about the second one? The x plus minus 3's cancel. So I have plus 1 times 2x plus 1 equals the 2x plus 1's cancel. 3 times x minus 3. So that whole crazy equation simply becomes, let's see, 2x minus 10 plus 2x plus 1 equals 3x minus 9. 4x minus 9 minus 9, subtract 3x. I get x equals, add 9, 0. I get x equals 0. That's it. X equals 0. Because the 9's cancel, the 3x move. You got nothing left on the right-hand side of this equation, so it's just 0. You must check it. You're not doing a full check. Here's what you're doing. Let me get the original problem back. You must check that the solution does not make any denominator equal 0. So in other words, if you plug in a 0, 0, you get negative 3, you get negative 3, you get 1. You're fine. Check, check, check. If your solution, suppose our solution was x equals 3. if our solution was x equals 3, well, 3 minus this would go to 0, and it would not work. But it's not x equals 3. So honestly, we're good. There's your answer. All right, Robert can paint a kitchen in 3 hours. Susan can paint it in 2 hours. How long will it take them to work together? All right, they each have a rate. Robert's rate per hour. If it takes him 3 hours to paint that kitchen, he is working at a third part of the kitchen per hour. Susan can paint it in 2 hours. So Susan's rate is half a kitchen per hour. The rate is always per hour. So, well, if we take Robert's rate and add it to Susan's, wait, let me redo that. Sorry about that. If we take the amount of work that Robert completes and add it to the work that Susan completes, we equal one whole job. And that's what we want to know. We just want to know how long will it take both of them working together. Well, the amount of work that Robert completes is simple because work equals rate times time. Well, we don't know how much time they're spending together, but we know Robert works at a rate of a third an hour times the amount of time he's going to spend on it. Now remember, Susan and Robert are working together, so they're going to spend the same amount of time. They're just going to complete different amounts of the kitchen. So Susan is a half times time. So this is the first one's the amount of work Robert completes. Then we've got the amount of work Susan completes to get one whole job. Get rid of your fraction by multiplying everything by 6. Because 2 and 3 both go into 6. So there's your common denominator, your lowest common multiple. So what do I get? I get 2t plus 3t equals 6. So it's 1 1/5 hours. That's how long they would do it together. 1 1/5 hours. And if you want to think through this logically, if both Robert and Susan took 3 hours to paint the kitchen, wouldn't it make sense they'd complete 1 1/2? They would complete the kitchen in 1 1/2 hours. But Susan works a little faster than that. So it's a little less than 1 1/2 hours. All right, let's move on. Number 32. All right, power to a power. Don't get scared by the fractions. Power to a power means I'm just going to multiply. I need 3/4 times 1/2 is 3/8, so that's x to the 3/8. Y is going to be 2/5 times 1/2. Well, that's y to the 1/5, right? And then I have x to the 1/8. So now I got quotient rule. That means I need 3/8 minus 1/8. Well, isn't that x to the 2/8, which is x to the 1/4. And because it is positive, it goes in the numerator. That's the answer. B. We have cubed roots. All right. every single thing inside this parentheses a perfect cubed. What's the cube root of -8? -2. A to the 12th, the cubed root of, well, 3 goes into 12 perfectly. It's A to the 4th. It's B to the 5th. It's C to the 7th. Everything was a perfect cube, so that one simplifies quite easily, actually. All right, 1/16 to the -1/4. First of all, the negative power flips it. You can look at it this way. You can do 1 to the -1/4. 16 to the -1/4. Because they're both negative, we can put 16 to the +1/4 and 1 to the +1/4. There's so many different ways to look at this problem, but this one's kind of, I think, makes the most sense. 1/4 means the 4th root of 16. And the 4th root of 1. Well, what number multiplied by itself 4 times gives you 16? 2 over 1, and the answer is 2. Radicals. You cannot simplify your radicals. I mean, you cannot add radicals together unless they have the same exact value under the radicand. So, we got to simplify. Square root of 32. Let's do this first. Let's do square root of 32. All right, what perfect square goes into 32? Isn't that 16 times 2? Don't forget the x that's in there. 16 pops out of a radical as a 4. So that's out. And then you're left with 2x. All right, so this one becomes 2 times 4 radical 2x. You can't simplify that. It's just 5x radical 2. Now, 18. Isn't that 9 times 2? The 9 will come out as a 3 radical 2x. All right, don't forget this first one had a 2 out front, so 2 times 4, so it becomes 8 radical 2x minus 5x radical 2 plus 3 radical 2x. The only ones you could bring together are those radical 2x's. So that's going to give me, you have 3 of them here, 8 of them over there. That's going to give me 11 radical 2x plus 5x radical 2. And that's how you have to write your answer. Minus. Sorry, forgot that was a minus sign. Minus 5x radical 2. Okay, B. You got to you just have to foil everything out. But be careful, because think about this. When I put those first two together, what is any radical multiplied by itself is just whatever's underneath without the radical, right? Because it would be x squared and the square root of x is just x. So wouldn't this be 5? Radical 6 times radical 6 is 6. Now, do the second one. Now I got to do 5x, so that's minus 5. Radical 2, radical 6, that becomes a 12. I did that one, so now let's do this one with this one. That's minus 2 radical 12. And then with this one, that's plus, again, 2 radical 4, which is another 2. 2 times 2. All right, clean it up. I can bring those middle ones together. It's at 7 radical 12. Clean it up some more. It's going to be 34 minus 7 radical 12. But here's the thing. That can be simplified. Seven times 2, because the square root of 4 is 2. That is your final answer. 34 minus 14, radical 3. Part C. You can FOIL it out if you choose, if you don't want to use that shortcut method that we talked about earlier, by just writing it out twice if you want to. That's fine. I like to get in the habit of squaring a binomial. You square the first term. You multiply 6 times negative, that's negative 12i, but you double it. And then it's 4i squared. You square the last term. FOIL it out, you're going to get the same thing. Minus 4i. Ooh, what's I squared, everybody? I squared equals negative I. So that's minus 4. So you should get 32 sorry about that. I forgot that was a 12, not a 2. So this is, I forgot the 24. Yeah. (32 minus 24i). Yeah, see, that was 12 inside, not another 2. 32 minus 24i. All right, rationalize the denominator. All right, when you rationalize a denominator, you have to use what we call the conjugate. The conjugate is almost identical, but a different sign in the middle. And unfortunately, what you multiply, you got to do the same thing to the numerator as well. So you're really just multiplying by the number 1. All right, so you got to FOIL everything out. I'm going to do the denominator first because it's so much easier. Watch. That just gets you 6, right? Square root of 6 times square root of 6 is 6. Here's why we use a conjugate. The middle terms are going to cancel away. You don't need to worry about square root of 6 times square root of 3 and then negative square root of 3 times square root of 6. They're going to cancel each other out. All you need to do is square root of 6 times square root of 6 and then negative square root of 3 times square root of 3. So it's 6 minus 3. Your denominator is simply 3. Numerator is a bit more complicated. We have to FOIL that. I'm going to start FOILing it. I get 5 radical 12. 5 radical 2 times radical 6 is 5 radical 12. Plus 5 radical 6. 5 radical 2 times radical 3. Now I'm going to multiply by square root of 3. That's minus square root of 18 minus, oh, square root of 3 times 3 is just 3. There's not a lot you can do to this problem. We can clean up each of these. 12 is, remember, 4 times 3, so the 4 comes out as a 2. So that ends up being 10 radical 3. 6 you cannot simplify. 18 you can simplify. 18 is 9 times 2. So that becomes 3. All right, notice even after doing that, we don't get any common radicals, so that whole thing is your answer. It's a lot, but that entire thing is your answer. I need to erase this, so I have room to solve the other problem. Same idea, you need a conjugate. Put everything in parentheses. Two minus 5i, 2 minus 5i. Conjugate, same thing. All right, do the denominator first, makes it easier. We don't need to worry about middle terms in a denominator. They're going to cancel away. 2 times 2 is 4. And if you don't believe me, FOIL it out. You'll see they're going to cancel away. Plus 5i minus 5i is minus 25i squared. I squared is negative 1. It's 4 plus 25. My denominator simply becomes 29. Numerator's a little more complicated. You got to FOIL. Let's FOIL it. 10 times 2, 20. 10 times that, that's negative 50i. Negative 4i times 2 is negative 8i. Okay, let's do this one up here. Negative 4i times negative 5i equals 20i squared, which is 20 times negative 1, which is negative 20. Did you catch all that? I'm just going to write that as negative 20. Clean it up. Oh, 20s cancel. Looks like I have negative 58i over 29, but these reduce to negative 2i. All right, radical. Notice the radical is already by itself. The only thing you can do is square it. To do that, you must square the other side of the equation. Square the radical just gives me this. Square the other side of the equation, you got to FOIL it out. Here's that squaring a binomial again. 4x squared minus. Multiply them together and double it. So negative 5 times 2x is negative 10x. Double it is negative 20x. Plus 25. Square the last term. I got to bring everything over. So what's that going to give me? 4x squared. I got to subtract the 2x. Minus 22x. Subtract the 1. Plus 24 equals 0. Take out a 2. You can go ahead and use your AC method if you choose. I'm just going to work it out quickly. It looks like if I multiply the 2 times a 4, that's going to give me 8, and then the 3. So, yeah, I think that works. Watch. Negative 3x. Yep, that gets me my negative 11x. I'm good. That's my quick guess and check method. Set each factor equal to 0. Forget the 2. 2, that doesn't, it's like you just divide out the 2. So when I have 2x minus 3 equals 0, I get x equals 3 halves. X minus 4 equals 0. X equals 4. Here's the problem. You must check each one back in the original problem. Just because you get it as an answer doesn't mean it's going to work. Watch. Check 3 halves. What's 2 times 3 halves? That's 3. Right? 3 plus 1 is 4. Square root of 4 equals 2 times 3 halves minus 5. 2. Oh, that's negative 2. You get 2 equal negative 2. Does not work. Got to get rid of that one. You check the 4. The 4 is going to work perfectly. 4 plus 2 is 8. 9, 3. 4 times 2 is 8 minus 5 is 3. That one's your answer. Cubed root. Oh, so now I'm going to take the cubed root of both sides. Much easier problem. Cubed root of cubed is just that. 9. Done. See, some problems are just that quick. All right, A. These are just solving equations, just more practice. They're going to get you quadratics. Right? You got to set equal to 0. It's a quadratic. Subtract the 12 from the 18 is going to give you 6x plus 2 equals 0. Okay, this one is not going to factor. You can try all you want. Your A is 9, your B is 6, your C is 2, and it's negative B. You got to use a quadratic equation. B squared work all that out, you get negative 36, I believe. That's 6i over 18. So you can leave it like that. You can split it up. When you split it up, this negative 6 over 18 comes out to negative 1/3. And then, of course, this side comes out to 1/3 I. So there's your answer. The next one, B. Again, quadratic. But this time you can combine things. You get 6x squared minus 27x. Okay, here's the difference. You don't have a C term on this one. You can just factor it using GCF. 3x is 2x minus 9, I believe. So you simply end up with 3x equaling 0, so x is 0 for that one. And for the other one, 2x minus 9, because remember you got to set each factor equal to 0. So you get 0 and 9/2 as your two answers. And that's it. Okay, determine whether the equation has one rational solution to, all you need is this part, the discriminant. All right, b squared is negative 5 squared minus 4 times 6 times 3, which ends up being 25 minus 72, which is negative 47. All right, so here's the deal. Remember, when you're dealing with the discriminant, a couple things can happen. If your discriminant equals 0, you get one real solution. If your discriminant irrational, I should say that, not real. Let's call it rational solution. If your discriminant is a positive number, and a perfect square, you're going to get two rational solutions. If it's positive and not a perfect square, you're going to get two irrational solutions. And if it's negative, you're going to get two complex solutions. So because we are negative, we get two complex solutions because you're going to end up with i's. All right, 38. Let's solve. Remember, you have a higher root, but you can, because it's x to the fourth and x squared, you can treat it like a basic quadratic. The only difference is you're leading sorry, you're going to have an x squared and an x squared instead of an x and an x. That's all. You still need two factors of 8 that add up to -6, -4, -2. Ah, but wait, that can factor further. X minus 2, x plus 2. That cannot. That stays x squared minus 2. The reason is that is a perfect square, so it can split up. Now, what are all my answers? Set each one equal to 0. X equals 2. X equals -2. Right? Because x minus 2 equals 0, so x equals 2. X equals -2. And plus and minus radical 2. So my answers are -2, 2, negative radical 2, positive radical 2. We're almost done. 39. Solve for t. Yeah, so this one is a bit more complicated. Get everything with a t on one side. And everything that doesn't have a t, move to the other side. So what did I do? I subtracted 4b from both sides and brought that over, and I subtracted t squared and brought that over. And that's going to give me 2t squared. Can't do anything with this, you just got to write it out. Divide everything by 2. Right? Divide by 2. And just take the square root of both sides with your plus minus. That's it. Remember, rearranging like one of the ones we did at the very beginning. All right, so here's my function. I need a vertex. So your vertex, the x value is -b over 2a. I believe that's at 3. To find the y value, you got to plug it in. So your y value is f of 3. Please notice that the negative is on the outside. Only the 3 is being squared, not the negative sign. That's why it's very important to only put the solution in the parentheses. Nine minus 5, you get 4. Okay, so my vertex is 3, 4. There's the vertex. All right, y-intercept, that's the easy one. You just do f of 0, which is 0, 0, which is -5, so it's 0. That's your y-intercept. X-intercept's a little bit harder. That's when you set equal to 0. So it's 0. To do this, let's move everything over and divide out a -1. Just divide out a -1. Because you can't really, it makes it easier to factor. And you can factor it into x minus 5 and x plus 1. Notice this is a quadratic, so it's very common that we would get 2 x-intercepts. My 2 x-intercepts are 5, 0. Remember, these are points. Write them as points. All right, I have everything I need now. Remember, my vertex was 3, 4. My intercepts were at 1, 5, And my y-intercept was at 0. 1, 2, 3, 4, 5. There you go. And there is your parabola. There's your quadratic. To solve and graph this next one, we're not graphing the parabola. We're just graphing it on a number line. We're graphing the solution on a number line. So for this particular problem, you need your boundary line. In other words, set it equal to 0 first and solve it. Okay? So, factor it however you want. This is what it comes out to. 3x, 4x, yep, negative 4x plus 3x, so it works out nice. I get negative 3/2 and x equals 2. So there's a couple ways to do this one. You can graph it on an equation. So we've got, here's negative 3/2. And here's 2. It creates these intervals. I'm going to put closed circles only because our original thing had an equal to sign in it. And all you're doing is doing your test points. So I would test 0. I'm going to test 0 because it's in between. So you test 0 in your original problem. I get 0, minus 0, minus 6. Check. So that means this area is definitely shaded. You can go ahead and test, say, 3. You can test negative 4. You can test these other points, and you're going to quickly see that if I test, they do not work. So that's what my graph looks like. 42, find the distance. So remember your distance formula. It just simply stems from the quadratic formula, actually. I'm not the quadratic formula, I'm sorry. It extends from the Pythagorean theorem. Oh, all right, just plug everything in. You want the difference in the x's. Be careful with your signs. Oh, this becomes negative 7 plus 12, which is 5 squared. 12 squared is 144. Oh, that's actually 13. Square root of 169 is 13. And finally, your circle problem. When you go to do your circle problem, put your x's together, leave a space. I'm just rewriting it. All right, so notice what I did. I put my x terms together, x squared minus 4x. Then I left a space because I'm going to have to complete that square. Then I put my y terms together, right? And I left a space because I'm going to have to complete that square. Then I took my 16 and popped it over to the other side. All right. So let's finish. Sorry. All right. To complete the square, I take negative 4, cut it in half, and square it. Well, that's negative 2 squared is plus 4. But because I'm adding a plus 4 there, add a plus 4 there. All right. Again, take 8, cut it in half, and square it. Half of 8 is 4. 4 squared is 16. Add it over here. I can go ahead. Oh, this is x minus, because this is minus, so notice the sign comes down. And what's the square root of 4? 2. y plus, and what's the square root of 16? 4. And that's 4. My center. Remember, the standard form of the circle has a negative, so that's okay that that's negative. It becomes positive 2. The standard form of a circle is minus. So that's actually minus a negative 4. So that's negative 4. It's opposite. Just remember that it's opposite of the sign that's given to you. You're going to see that when you get into pre-calc 2 and you're dealing with parabolas and some other ellipses and hyperbolas and stuff like that. The radius. Square root of 4, which is 2. Okay, that completes our review. I hope you found these 2 very long videos helpful.